use of designer tool and what is the use of RT tool. Right? So now coming to this JMAG Express tool. Right? So the JMAG, so this is the workspace for the JMAG Express tool, and this JMAG Express tool is having the template model. Right? JMAG Express tool is having a template model, whereas the yesterday we discussed about the magnet package, so that is not having a template model. Whatever diagram we need, that we can draw. But if it is a template based one, if it is a template based design, we can able to draw have a template based model here. We can able to make any motor, any type of motor we can able to make here. Right? So it can be a BLDC motor, it can be a PMSM motor, it can be outer rotor machine, or it can be inner rotor machine, induction motor, or a switch rotors motor. Any type of motor we can able to make here. Not only the template based one, but also we can go for a new type of structure in the motor model by using a AutoCAD file in the form of DXF model. Right? Suppose the constant structure is not needed for us. We are going for a different type of structure. Right? So in that case, we have to go for a build new combination. We have to go for build new combination model here. Right? So what happens? We can able to have different type of combination. What is the basic combination? Standard one, spoke type, and all the different types of combination of rotor is available here, and different type of combination for the stator also is available here. Right? So whatever we want, we can able to prefer. So for simple understanding, just take the basic model of the rotor. Again, I just prefer the basic model of the stator. Right? We can go for any combination. This is not the finalized one. We can go for any type of combination here, right? And then just give OK. Right? So now we can able to see the model here. We can able to see a model of the machine. So this is the model of a machine, right? So there is no need to give any standard diagrams to draw here, right? Suppose if you want to draw, that also we can able to, that I will tell later, right? So this is the initial stage, right? This is the initial stage and the introduction of the JMAG tool. So how to make the package very useful in a efficient manner to make a simulation one, right? So now, suppose if you know only the rated power of the machine, we do not know the remaining outer diameter as well as the inner diameter of the rotor and the stack length of the machine. We do not know. So in that case, I just give only the rated power, right? If I give only the rated power here, just if I give 2 kilowatts, so 2 kilowatts motor I needed. So in that case, I just give only 2 kilowatts, then I give just apply, right? Then the remaining dimensions will be assumed by this package. So that is the beauty of this JMAG, right? If you know only the kilowatt, we can just give the kilowatts, right? So the remaining dimensions. So if we go for the dimensions, so you can able to see the outer diameter is 68 and the air gap is 0.3 and the gap type is free, or we can able to keep it as fixed one, right? The fixed means it is 0.36 only. Otherwise, we can such that we can able to vary the air gap, right? And the stack length is 68.86 mm. Suppose if I want to generate only one kilowatt and I give apply, right? If I give apply, we can able to see the dimensions here. See, the dimension has been changed to 54.65. So depend upon the kilo, the JMAG itself will decide the outer diameter for the machine, right? So that is the beauty of these packages. Suppose if you know the maximum torque, so we can able to provide the maximum torque, right? So what are the details we can able to give here? It is not a compulsory one. Suppose if you know only the rated power, the rated power is only enough to make the machine. I just give apply here, right? So the remaining part, that is the dimensions. So the dimension will be fixed by the JMAG itself. Suppose if you want to change the topology, change the design model of this data, only this data. If you want to change the design model for only this data, just give modify here. So that what happens, the entire thing, the entire different types of template will be visible now, right? So depend upon the template, we can able to choose what template is needed now. Suppose we don't want any template here, right? I don't want to choose other template. I want to edit in the current template itself. So just give edit current template and then give OK, right? So editing option will be available here. I just give OK. So this is the editor page now, right? Suppose if you want to edit any coil, we can give the editor manner, right? So this is how we can go into edit the coil. Suppose I don't want to edit anything, just go back here and destroy and return, right? So it will go back to our original page, right? Now, and the second one is, now I want to modify the stator with a new template of the motor. Suppose I have only the AutoCAD file, I have only the basic AutoCAD file, then that is enough for us. So just convert into DXF file, or if you are having a magnet file, just convert into DXF file or JCF file, any file. Just convert the file into DXF or JCF, and we can able to import, right? And then give OK here. Now, similarly, suppose if you want to change the outer diameter, just rename this one. Just press F2 button so that we can able to rename and just check it out. I just give 55. See, the outer diameter can be increased to 55. Similarly, everything. Similarly, suppose the bore diameter. If I want to change the bore diameter, I can go for the bore diameter changing. Right? So I just give 66.7. So it is going to 66.7, right? But it is not a perfect design, so it is giving some error, right? So I just go back to that. Now similarly, this is for stator. If you want to rename anything, just give the F2 button in your computer, so that the entire design we can able to alter without changing the template, right? And then give the, suppose if you want to change anything in the rotor side, see the entire, after fixing the motor template, we can able to change the design here, right? So this is the beauty of this package. Suppose if you, the beauty of this package is only one thing. If you want to design a machine, suppose if not having any of the dimensions, just give the kilowatts rating. The entire thing will be fixed by the design itself. And then if you are getting the outer diameter, right? If you want to get in the outer diameter, just give the outer diameter of the stator, and the remaining things will not be altered, right? Now once again, suppose I just go back to the basic one. This is a basic model, right? This one is the basic model. Now I just go to the materials. I just go into the materials. See here, the material, that also will be there, right? Suppose the coil means it is a copper, right? Coil means it is a copper, or you can paste it as a aluminum, right? So whatever option we need, we can able to fix it here. Suppose if it is a stator core, again we are having a category for different type of steel material, right? We can go for any type of steel material, whatever we need, right? So similarly, with that, in that category, there is large number of material. What material we want, we can able to choose here. Suppose I want to choose my own defined material. So in that case, just go to the custom steel, and then we have to give the, what is the material name? We have to assign the material name as well as the BH curve here, right? Now I don't want to go to the basic one. I just stay back here itself. Right? I just stay back with the basic steel. And then similarly for the rotor. In the rotor magnet, it is a NdFeB, it is chosen. Suppose if you want to choose any other magnetic material, just go for the ferrite type or go for any other NdFeB material, right? But prefer the ferrite type NdFeB model, neodymium model. And coming to the rotor core is also a laminating core material, and this core material also we can able to change. So the category also we can able to change. Similarly, and the model, what is the model, product model also we can able to change here, right? For everything we are having a BH curve, right? Depend upon the BH curve only we are going to choose. Now coming to the windings. So winding is the beauty here, right? So we know how to make it. So this is the winding diagram with the motor. And now if it is a star connector, we can able to see the diagram here, right? Suppose I change the star connector into a delta connector one. I just change the star connector into a delta connector model, right? And then, and the winding scheme is, I just make it into concentric winding. See, the concentric winding diagram also can be obtained here itself. There is no need to draw separately in the any AutoCAD file, right? Just if you want to make an automatic file, we can able to get it, right? In the same way, suppose if you want to make any concentric file, we can able to get it. Or if you want to go for a manual, and then we have to give the path where it is going and from which where it is going and from where it has to come. So that we have to give for different U, V and W phases, that is RYB phases. Now I don't want to go for any thing, right? I just go for the automatic model, right? And then the another beauty of this package is, suppose if you don't know anything, you don't know how many number of turns we have to keep, as well as what is the wire diameter and what is the thickness and what is the standard and what is the insulation thickness and what is the slot fill factor. If all this data is not known, but you know only one thing, that is the phase resistance. If we give the phase resistance, automatically the entire thing can be changed, right? Here the phase resistance is mentioned as 0.01761, right? Suppose I change the phase resistance depend upon my requirement. So I just keep it as 0.5, right? If I keep it as 0.5, then automatically the entire thing can be changed. Suppose depend upon the phase resistance you are keeping the winding design. Not only depend upon the phase resistance, we can able to keep depend upon the turns per wire size as well as the turns per slot fill factor and wire size per slot fill factor and phase. So depend upon all these factors, we can able to give the winding resistance. So again I go back to my default case, right? Suppose if I want to know the winding diagram, right? So at the top of the tool we can able to see some options such as motor diagram, winding diagram, and then slot diagram, and then characteristics, right? So all these things, winding diagram. Suppose if you want to know the winding diagram of this machine, not only for this permanent magnet machine, you can go for a synchronous lattice motor, induction motor, anything. The procedure is same, right? So how to make the winding diagram is it is same here, right? So there is no need of any difficulty for drawing the what is the current direction we have to give, whether it is dot or it is cross. So that is not needed here, right? So just give the automatic option or just go for the concentric type of winding, right? So anything we can able to give you and just go for the slot, right? It is a slot based one, right? And now phase order, we can able to change the phase order also if you are going for the manual type of operation. Suppose if it is a manual type of operation, we can able to go for change in phase sequence, that is UWV, and then we can go for UVW. So anything we can able to make here, right? Now, so this one be the winding diagram. So this winding diagram can be taken here, right? This winding diagram can be taken and just use it for the our publications, right? Similarly, the slot diagram. The slot diagram can be taken as it is, and then we can keep it in the publication. Now coming to the characteristics, right? Coming to the characteristics, see, so this is the winding machine dimensions, right? Machine dimensions as well as the property of the motor, right? So we can able to see the winding, what type of winding I have chosen here, whether it is star connector or delta connector, or even it is a series number or a parallel number of turns. So anything we can able to see, right? And the beauty here is the yellowish color. The yellowish color, what and all it is indicating, we can able to go for the optimization. We can go for optimization. That is the beauty of these packages. In other packages for optimization, we have to go for different packages. Whereas in JMAG, the optimization is given in the same packages, right? So there is no need to go for different packages and all, right? So now, and the next one is drive. So what type of drive we are going to use now, right? Whether it is a current driven model or it is a voltage sign driven model or it is a voltage with 120 degree phase displacement, right? So that can be chosen by us. And then similarly the peak line current, right? Again, if you want to change the peak line current, just give the rename option, that is press F2 in our keyboard, so that we can able to rename the option. I just give 6 ampere, right? Now, if you want to change the current phase, again that is also the same thing. Just give F2 button, we can able to change the current phase. If you want to change the speed, just give F2, again change the speed in the machine. Now, so after simulating it, we will be getting some graph. We will be getting some graph here. So that graph should be referred with either the line current or the phase current or the speed of the machine, right? So all these three options we can able to get the characteristics, right? So now I go for the speed option here. Now I go for the speed option here, right? So now what I am going to do here, I just given the speed option here. Now the thing is ready now. Now the thing is the machine modeling is ready now, right? So for the operating mode there is two modes. One is quick mode, so that is found at the top of the left side corner. So different type of mode. One is quick mode, another one is power mode, right? So which mode we can want, we can able to choose here, right? So if you go for the power mode, there is lot of thing is needed, right? Whether the analysis period that should be depend upon the speed or the analysis period that should depend upon the accuracy of the design, right? So anything we can able to choose here. Now coming back to our load, whether the load has to be included, then also we can able to include here, right? And inductance parameter, efficiency map. So everything can be done here, right? Whereas in some other packages, the efficiency graph will not be available automatically. Whereas in case of JMAG, the efficiency graph will be available, right? Directly it can be taking the efficiency graph. So now for the time constraint, I just go for the quick mode of operation, right? So the time consumption will be less, right? So now what I am going to do, I just go for evaluation of this model. I just evaluate this. So at the top, that is below the characteristics option, there is a evaluate option, that is this one. So this is the evaluate option which is in the yellowish color. So after evaluating, I just have some characteristics here, right? I have some characteristics here, right? So I just get the characteristics of torque, right? So which I gave as 2, right? Which I gave as 2 Newton meter. Again, now the efficiency graph is this. Now I just get the power graph, right? Copper losses graph. Similarly, iron loss graph. See, in all the things, the x-axis is speed. The x-axis is speed here, right? Similarly, the power factor is obtained, phase voltage, and then the line RMS voltage is obtained. Coming the magnetomotive force, that is the MMF also we can able to obtain here, right? Yeah, but this MMF plot is not available in some of the packages, right? Some of the electromagnetic packages, whereas here the magnetomotive force is available, right? Now previously what I mentioned, the x-axis can be changed here. The x-axis can be changed not only for the speed of the machine, but also for the line current of the machine. We can get the graph here, right? So now I just go for the evaluate. So after going for the evaluate, again I can able to get the x-axis graph as the line current. I just give 6 ampere, so I just get the x-axis current, right? X-axis as the current here, right? Now again we can go for the phase current. We can go for the phase current and then give the evaluate option, right? I just give the option evaluate, which is found at the top, that is below the characteristics option.
We can put the video. I didn't try.
So now what happens? I just get the x-axis as phase current. I just get the x-axis as phase current, right? See, everything can be changed here, right? So that is the beauty of this package, right? Now, suppose if I want to edit these characteristics, I want to edit this characteristics. So what I want to do, just there is an option at the top. The last option at the top here is edit characteristics. The last option at the top here is edit characteristics. So now we can able to see some options here, right? See, suppose if I not clicking here, we can able to get a different type of white color background for the characteristics, right? Suppose if you want to go for the edit characteristics, the background now is getting changed, right? The background is now getting changed, and then if I want to edit something, I can able to edit here, right? I can able to edit here, right? Now, if you want to include more number of y-axis, if you want to include more number of y-axis, just include here,
Yeah, they will deduct.
right? So that is the phase current. Like that we can able to change it, right? So anything, suppose if you want to change the line into a dash line, right? So I just give here, right? Suppose,
It's a good healthy strength.
so this line is now getting into dash, right? Dashed line. See here, it is not a continuous line, it is a dotted line. It is a dotted line here. Again, if you want to change something, the width of the line, I just give 5 width here.
I got the point about.
See, the width of the graph is now changed. The width of the graph is now changed. So similarly, the alteration for our publication. Suppose if you want to change this one into an ellipse symbol, that also it is possible, right? There is no need of to take this model to a MATLAB file, right? If you want to change anything, we can able to change it here itself. There is no need to go for any MATLAB file and right? There is no need to go for any MATLAB file. We can able to change it here itself. So this is how we are getting a different symbol, right? Now I want to get only that symbol alone. Just give this, right? So now see here, we can able to alter the graph here, right? So this is how we are now able to alter the characteristics, right? So now, so similarly we can able to alter the efficiency characteristics, right? We can able to alter the efficiency characteristics, right? Now, efficiency as well as the power characteristics, copper, all characteristics we can able to alter, right? So that is the beauty of things. And then now previously I mentioned that we can able to change the optimization. What is the yellowish color? The parameter for the motor which under yellowish in color can be used for the optimization, right? Suppose if I'm taking the outer diameter, right? If I clicking on the, just I will click once again on the outer diameter that is yellowish in color. If I click on this yellowish color, a tab is open, that is the input parameter tab. Now I want to go for optimization, right? So I just get this tab here, right? Suppose the optimization starts at 54.65 and ends at 55.65, right? If you want to change, just type it here, we can able to get some different one. I just go for 58, I round out the values, and now the division, how many number of division the range should vary, right? So I just give some 6 here, right? And then go for the evaluate option. If I go for the evaluate option, I can able to get different type of characteristics. So which is best, I can able to choose here. Right? It is now solving. So just 1 minute, in 30 seconds will be ready. Right, the optimization is now ready, right? So now, if you see here, so this is the optimization graph, right? So the iron loss is now varied somewhat largely, right? So only we are able to get different type of line, right? So one is for the minimum value, another one is for the maximum value, right? So every varying parameter is now plotted as a characteristics, right? See, we can be able to see the line voltage variation, we can able to see the variation in the phase voltage, we can able to see the variation in the iron losses, we can able to see variation in the line voltage. See, every variation is now plotted as a characteristics, right? If you go at the top bar of the characteristics, there is different option is available, right? Now, see here, the outer diameter what I kept here. The outer diameter at the starting it is now for 54.65, right? So I just give 6 divisions. So it is 1, 2, 3, 4, 5, 6, right? So all the 6 division is now analyzed, right? All the six division is now analyzed and the characteristics is now obtained, right? Suppose if you want to change the air gap length, right? So the default air gap length here is, it is 0.285 and the air gap maximum we can vary is 1.2. Now I just go for the division variation as 5. I just give the variation for 5 so that we can able to see the characteristics. So how we can able to predict the characteristics and what is the higher efficiency, right? So optimization by using this JMAG, it is very easy for us, right? So again we have analyzed the optimization, right? We have analyzed the optimization for the air gap. So if you have change in the air gap, see the efficiency also is now getting slightly changed, right? There is a big deviation of the efficiency graph, right? As well as the iron loss characteristics, line voltage. But when I go for publication, just go with the x-axis for the speed, right? If you go with the x-axis for speed, that will give the better analysis idea, right? Right? So going with x-axis for the speed, that is a better analysis idea. Now suppose if you want to change anything, so the procedure is same. If you want to change anything, we can able to change like this. Just click over the option what you want to change. Whatever yellow in color, we can able to change here, right? Whatever yellow in color, we can able to change. So the remaining things that under cannot be changed here, right? The optimization is not applicable for the thing which are in the black in color, right? Which are in yellowish color, we can go for the change here, right? Now if you go for change in the magnet width, again it is same, right? And just go for the division as 3. I just go, but don't close it, right? If you close this one, the evaluation will not take place, right? By evaluating, this tab should be open, right? So most of the people will go, this one is wrong. Just they will do everything and just they will close this, right? So in that case, you should not do this one, right? Just go for the evaluate option. Then only it will, evaluation will be going on. Otherwise, evaluation will not go for the optimization, right? Right. So this is a default data. So only the error is showing here. Right? It is going to take only two values. Right? It is just taking only two values. Right? So we can able to see the value here. Right? Now, so now what I'm going to do here is I just want to export the evaluation result. I just want the data of this result. Just go to the option here, which is found at the top of the toolbar. Just below the help option. That is below the help option. We are having a option as export evaluation result. Just click this one. We can able to get everything in the form of TXT file. That is Excel sheet, right? So just save this file. We can able to get everything in the form of Excel data, right? So now what I want to do here is I just save this file, right? I just saved this file, right? Now I want to save this file in the option of two. One is in the form of JMAG designer, another one is in the form of RTT model, right? So if I go for the JMAG designer, right, just click this option, right? So the option is available at the top of the toolbar. So just below the tool option, right? So we are having file, edit, view, template, sizing, characteristics, tool. Just below the tool option, we are having a JMAG here. We are having a JMAG designer, right? If If we click this one, we can able to go for the JMAG designer, right? So there will be option is asking whether you want to export a 2D model or you want to export a 3D model, right? So moreover to this, suppose if you want to export only half of the model for the machine, just give the partial model. Suppose if you want to export as it is in the JMAG Express, just give the full model option, right? And then give okay. So now our JMAG designer is opened here.
Prabhu, you can check the audio. Audio is very, very low.
Sir, hello sir.
Yeah, perfect, perfect, Prabhu. You can continue.
Okay. So if you just export the model to the designer, we have a option as runner, right? We go for the runner automatically, right? We don't need to do anything. If we just export the model from the express to the designer, the run option will be taking place, right? So if you go for the customize, there will be option as torque, right? Just give the three type of coils. So what are the current that is flowing? So that also can be visible here. Right? See, we are having option as current in coil. So three phase current is available here. Similarly, torque option is available here, right? So if you want to see some more option as flux, so the flux also can be possible. Here, right? So we can able to see the coil current as well as the flux in the coil as well as the torque of the machine while the motor is running. Whereas in other packages, while the motor is running, we cannot able to see what is the current here, right? What is the current taken and what is the torque of the machine. But whereas in this case, we can able to obtain the value of the torque or value of the current, value of the flux, whatever we need, we can able to see when the simulation is going on. When the simulation is going on, we can able to see everything, right? If you want to check the flux density, that also is possible. Everything is possible, right? In case of JMAG, right? In case of JMAG, everything is possible, right? So this is the flux density value. This one is the flux density value. Now the result is ready. Here, right? See, so this is the workspace for the designer. This one is the workspace for the designer here, right? Now, so if you go for the designer, right? So what are the parts? So if coming to the parts of the motor, it is coil, stator core, rotor magnet or rotor core. So what are the material we assign there? The same material will be imported here itself. There is no need to just import some other material. Suppose if you want to change anything, see at the toolbox which is found on the right side of the workspace, we are having a toolbox here, right? So this toolbox will have the materials, different type of materials. Suppose if you want to change the material name, just click this material name and drag it and place it here. So wherever you want, you just drag it and place it there, right? So I will just show you. See here. So if you want to change the material, just drag the material whatever you are taking from the right side corner and then just place it here, right? So we can able to see the change in color. So that means the space is ready to be occupied. Just click the material from the material toolbox and then drag it. Just click and then drag it, right? We can able to see here. Suppose if you want to know the characteristics of this material, just double click the material. So whatever material you are having, just double click the material. Suppose if you are using a copper, just double click the material, right? We can able to see the characteristics and the thermal properties of the all materials, right? So depend upon this thermal properties, the temperature rise in the motor will be analyzed, right? So there is different options. Suppose if you are not exporting the motor design from the JMAG Express, so what you have to do, you have to draw a design here. You have to draw a design, or you can able to export a AutoCAD file for your motor own template, and you can able to import here, right? If you go to the file option here, you are having an option as import AutoCAD file. Just if we click this one, we can able to get an import AutoCAD file option, right? See, there is different type of option is available, right? We can able to import SolidWorks, inverted, solid edge, AutoCAD, anything. So whatever format we can able to choose, just import this one, right? If you are having a different type of motor model, suppose if you are going for a template based motor model, don't go for the AutoCAD diagram or anything, just use the JMAG Express, right? So that will be better convenient for the motor design, right? And then now coming to the conditions, that is the boundary conditions. See, the boundary condition is here, right? So this is for the dot and cross option, right? The condition here, it is UV, that is U, phase A, phase B and phase C, that is UVW coil, right? So this coil is having dot and cross polarity. See here, we can able to see the dot and cross polarity also. So that also will be visible, right? Suppose which is a motion component. So everything, suppose if you are using a JMAG Express model, everything will be just transferred to the JMAG designer. Suppose if you are drawing a one magnet model, one motor model, so in that case you have to give our boundary condition here, right? So this is the boundary condition which is found at the right side of the workspace. That is the conditions. This is the boundary condition. If it is a rotatory option, just click and keep it here, right? Such that this model is rotating model, right? If it is a translation, that is a linear machine, just click here and then drag here. Then this model will be rotating in the form of linear, right?
Perfect.
It's a motion, it's a rotatory motion, means just click and drag here, right? So this is also a different type of boundary condition. Translator means a linear. Again, this can be a form of a linear option. Suppose if you want to give a force as a boundary condition, right? If you are going for a one drawn model, you are not exporting a design from the JMAG Express. So all these things you have to give. You have to give our motion boundary condition, you have to give our force boundary condition, right? You have to give our heat source as the boundary condition. So everything we have to give, right? Whereas if we express model is there, if the express model is there, nothing is there to give. Just export this and automatically the machine will be running, right? So that is the beauty of this packages.
Because it will come one after another.
Now, if you want to mesh this one, if you want to mesh, right? Just right click this, because the machine is run already. We are having a mesh here. Suppose if you want to see the meshed model of this, just at the bottom of the tool option, we are having a view mesh option. Just click that one. We can able to see what is the mesh parameter here and how the mesh is done here. Suppose just we can able to zoom in and zoom out, and we can able to see how the mesh is available, whether it is available in the form of triangle or in form of any other shape. Suppose if you are not having any much knowledge with the meshing option, just give run option. The meshing will be done automatically. Suppose, so just go to the properties of the mesh, right? So the option will be having as standard meshing, slide mesh, generating mesh at each step. Just go for the slide mesh option. That is the better one, right? And when you go for the element size, right? So it is set automatically, right? It is set automatically. Suppose if you are setting the element size, just set as 2.5, right? Set as 2.5 and slide division, right? Next one is slide division and solid modification. So all these things you have to give if you are going for your own diagram, right? So in order to avoid this, just go for our template model, right? and then give okay, right? So this is the model length. So this model length should be as big as needed, right? Then only you can able to get the accurate result, right? And then give okay here. Now what I want to do here is I just want to check what is the results, what are the characteristics that I can able to see here, right? So now I have designed a motor, right? Since I designed a motor, I want to check the plots here, right? So what are the characteristics are available? What are the characteristics are available? For that, I just go for the right click option of the result and go for the new counter plot. So there is a result type of option that is magnetic flux density, right? As well as the magnetic field strength, magnetization, current density, Lorentz force, nodal force. So everything, displacement, Joule's law, everything, losses, everything we can able to see here, right? So after selecting what you need, just click here, apply. We can able to see the maximum value as well as the minimum value,
Once
right?
you get that soft
So the
copy,
color
you will
also will
be able
indicate
to
the maximum value as well as the minimum value. Now I
easily
just
conduct
change
the
into
last
magnetic
copy
flux
type.
density and then give apply here. So now we can able to see the maximum value as well as the minimum value here, right? I can able to see the maximum value and the minimum value, whereas the maximum value is 2.4 Tesla and the minimum value is 0. The minimum value is 0, which is found at the outer core of the machine. Now I want to see where, what is the instant of maximum flux density when the motor is rotating. Just I click the play option. So now we can able to see,
Argo is doing lot of work.
now we can able to see when the motor is rotating, so how the maximum and minimum flux density is now changing, right? So depend upon the rotor position, the maximum flux density and the minimum flux density is obtained here, right? Suppose I want to check out the flux density at a particular instant of the motor, right? So in that case, if I click here, I will get the value of flux density, right? I will get the value of flux density here,
See, some
right?
work only you have to bring.
If I click here,
You cannot, keep
right?
extending. See, you are a designer. You have to take care of design part. Small typing work only.
If I
you can
click here,
make use of
or
these
if I
people.
click here, the value of flux density, right? So if I want to check the instantaneous value of flux density, if I click here, we can able to see. Suppose if I am seeing the magnetic field strength, right? If I give apply, so the magnetic field strength maximum and minimum also will be
15 minutes
obtained
you
here,
can
right?
type it.
So similarly for everything,
He will do the design.
magnetization, right? Current density, everything will be applicable here, right? So the current density is maximum value is 1.1 into e power 6 ampere per meter square, right? So every data can be obtained here. Now what I needed here is I just want to make this one into a characteristics model. It is in the form of plot, right? But I want this plot in the form of characteristics, that is a graph model. So what I want to do here, right? I just cancel here everything and then go to the option in the project manager toolbox. I just have an option as graph. I just right click here, right? In the graph, I just right click here and then there is option as show table, right? I just click the show table. See, I can able to have the value of torque with respect to the time, right? With respect to the time, I can able to get the value of torque here. Similarly for joules, right? That is losses, right? Hysteresis losses with respect to time, and then with respect to the parts, different parts of the motor also I can able to get. And what is the value of current that is obtained, and then what is the value of circuit electric power, that is the power in the coil, and flux linkage value, rotor displacement, and the velocity of the rotor. So everything can be obtained here, right? Now I see everything can be obtained. Now I want to take this one in the form of a data, right? So in that case, what I am going to do, I just go for the export all result. So now, so everything will be saved in the form of CSV file format, right? So this one is the data for the result, right? I just save this one. So everything will be saved in the form of this one, but I need it in the form of graph, right? So for taking this graph, what I am going to do, I just go for the graph option here and then go to the torque characteristics, and then go for the option as show. Right? If I go for this, I can able to get the characteristics of torque. I can able to get the characteristics of torque. Now I want to export this characteristics. I want to export this image, right? So I just go for the export image option, and this image can be exported in the form of either PNP or in the form of JPEG. So any option if you want, you just save this file, right? So we can able to save this characteristics, right? And then we can able to edit this option, right? We can able to edit or we can able to print this option, right? If you want to edit the characteristics, so we can able to use this one, right? So by using this option, we can able to edit it. Suppose if you are going for the linear scaling option, or if you are going for the logarithmic scale option, we can able to go for the logarithmic scale. Or if the precision value, I am just reducing the precision values, so the precision value also can be reduced. So everything can be reduced. So this is common for both x-axis as well as for the y-axis. Suppose if I want to go for the tick marks, I just domain, instead of domain, time. Suppose if I go for the step, right? So that also can be possible, right? So everything is possible with this case of JMAG, right? Now, so this data can be taken in the form of the table, right? Just copy this one, and we can able to save this, right? And then line option. So this one is a line option one. So now, right, I just close this graph. So now similarly, we can able to take any graph here, right? Similarly for the Joule losses, similarly for hysteresis losses, similarly for eddy current losses, similarly for circuit electric power, similarly for coil flux, anything. For anything, if you want to know the characteristics, we can able to get the characteristics plot, right? So this is the plot for juice characteristics. And now we are going for hysteresis plot. It is showing as 0 because it is not a exact design. It is a rough design only. Circuit element. So what are the elements here, right? So current in the circuits, right? So current in the circuit, but still now we didn't see the circuit model here, right? So what about the circuits here? Suppose if you want to go for a circuit, so definitely there is a need of a circuit here. There is a need of a circuit here to run the machine, right? So just right click the circuit option just below the project manager, and then click the option as view. We can able to see the view option. We can able to see the circuit option here. Whereas this circuit option is only readable. We cannot able to edit this one. Suppose if you want to edit, just click this one, and then right click this one, and click the edit option, right? So like that we can able to edit it, right? If you want to include any voltage source, if you want to include any ground source, or if you want to include any inductance diode, so everything is possible here, right? Everything is possible here, right? So any editing we can able to do here, right? So everything is possible, right? So that is the circuit model which is controlling the operation of the motor. Now again the remaining graph for the coil flux linkage graph, right? So this is the graph for coil flux linkage, and now we are having a lot of characteristics will be available here, right? Lot of characteristics we can able to take, right? That is FEM inductance, coil inductance, so that also is possible. Similarly, the iron loss graph. So everything is possible here, right? So there is no need for going for some other packages, right? So most of the characteristics is available in this packages itself, right? So this is also one of the beauty of our model. This is one of the beauty of our JMAG packages. So what are the different analysis we can able to do, right? So after exporting this one, we are having two options. One is 2D model untitled, another one is steady. They are different, steady here, right? So just right click the 2D model, which is just imported from the JMAG Express, and then click the option as new study. We are having option as static analysis, we are having option as transient analysis, frequency analysis, So structural analysis, so every option we are available, right? So the drawback here is the mechanical analysis, that is the structural analysis, will be somewhat difficult in case of the JMAG, right? So that's why yesterday I told that for the mechanical analysis, just prefer the ANSYS packages, right? So remaining things, so this is the best one. Apart from this, the electromagnetic analysis, the best thing is the JMAG, right? So now previously I told that the efficiency graph is available in case of JMAG, right? But still now I didn't show you the efficiency graph, right? So to get the efficiency graph, what I'm going to do here, I just go back to our Express packages, that is JMAG Express packages. So in this case, what I'm going to do, there is an option as below the tool, there is an option as JMAG. Similarly, there is an option as RTT, right? So RTT is nothing but it is JMAG RT model. Just click this one, right? And then browse the space where I want to save this model. Just save this as any name as you wish, right? So I just save it as JMAG. I just save it as the JMAG option, right? Suppose, so this is another beauty of our simulation packages, right? So copy files required for the simulator. Copy files required for the simulator. That means we can able to couple this motor. We can able to couple this motor with a simlink, that is MATLAB, with the electric signal as the input, current signal as the input, voltage signal as the input, or we can able to couple it with the PSIM. So this option is the one of the wonder, right? So this is another beauty of this packages. We can able to couple the exact model to the MATLAB without using a external compiler. Without using external compiler, we can able to couple this motor with the MATLAB packages, right? Or PSIM. So that option, if you want, we can able to enable, right? And then give OK, right? I just give OK here. Now I'm going to create a JMAG RT model. So JMAG RT model is nothing but a model which is for the purpose of drawing the efficiency graph, which is for the purpose of drawing the efficiency graph. So now I think it is ready now. So now we are going for the JMAG RT model. So in the JMAG there is different one, right? So one is JMAG Explorer, JMAG Express, JMAG Portal, JMAG RT. There are different options available in JMAG, right? And then RT model, right? So this RT model is very important for getting the characteristics, right? So now what I want to do here is I just want to make this. I have created a RT file. Previously I have created an RT file here, and this RT file now I want to import into this RT viewer. So that I just open the file. I just saved here as JMAG. I just citing the JMAG file, that is which is saved in the form of .rtt, right? I just open here. Right, I just opened here. If I maximize this size, I can able to see what are the options are available here, right? What are the options are available here, right? If I click the option as more, at the bottom we can able to see, there is two options. One is the efficiency graph. One is the efficiency, that is found at the bottom of the table, which is found at the bottom of the workspace. There is two options. One is efficiency mapping. Another one is torque speed characteristics. One is efficiency mapping, another one is torque speed characteristics. So that also can be taken by using the JMAG packages, right? So now I just setting the maximum voltage as 250 watt and maximum current as 4.01. So coming to the motor control. The control type is depend upon anything we can able to control, right? Either we can go for the value of ID control, or we can go for a maximum torque or current control, or we can go for maximum torque or flux control, we can go for maximum efficiency control, maximum force or flux weakening control. So the basic control here is maximum power, right? So I just go for the control type of maximum power here, right? So when I deal with power, I just want to check this maximum speed also. Maximum speed mentioned here is 30,000 RPM, right? 30,000 RPM, but it is not exact design, it is only
Is that
the
I
rough
need
design
one by
available
time
here.
to do that?
I just mentioned only the rough design.
Then you can
Now
convert
what I'm going to
everything.
do here is I just
Unnecessarily your
select the option.
Tanya
I
also
just
you
going
can
to
do
select
that.
the option which is found at the bottom here.
What happened to that feed? No. How many 30 questions already we have uploaded, no?
I just select the option which is found at the bottom, that is efficiency map,
You have to put 30.
right? I just select in the efficiency map here.
I need to, tomorrow I will
So the
do
efficiency
24
map is
questions. You
generating.
put it
The
and send
efficiency
it.
map is generating now. So this is the one of the beauty of this package, because most of the packages for the hydromatic analysis for the motor
Go for
will not
certificate.
give the
Before
efficiency
attaching,
graph
I need to see the
directly.
proof.
Will not give the efficiency graph
Okay,
directly, right? So whereas in case of JMAG, we can able to get the efficiency graph directly as easy as possible. So it is generating. It will take some 2 minutes to generate the efficiency graph, because efficiency graph will be plotted across two parameters. One constant is torque, and another one can be for the anything. It can be for speed, it can be for current, it can be for losses, flux density. So three characteristics among that one, three parameters among that one is efficiency. So that will be common one with a variation of two parameters, right? So the graph also will be very attractive in color. So with the use of this JMAG characteristics, we can easily get good publication, right? The publication point of view, if you go for a publication point of view, the characteristics is easily available, and we can able to save the characteristics also is very easy. And the time consumption, and coming to the time consumption for the analysis or design the motor is very less here. It is creating, we just take some minutes here. So why it is taking some more time means I exported the model as full model, right? Suppose if you want to reduce the analysis time, you can go for the partial model also. You can go for partial model, right? We can wait for some 2 minutes so that the efficiency map is creating. So in the meantime, we can see some other thing, right? It will make creating, so it will take some time, I think so. So now what we are going to do here is, so similar to the JMAG, there is another packages. There is different packages. So that one is motor solve, right? Similar to the JMAG, there is another package that is motor solve. So with this motor solve also we can able to create a model. We can able to create a model depend upon the template or depend upon the AutoCAD file, depend upon our own design or depend upon the template which is available, right? So that one is said to be as a motor solve model. Right? So this is also one of the good packages. This is also one of the good packages here for solving the motor. again I just tell that when you go for the motor design, only the electrical design is not a needed one, right? We have to go for the mechanical consideration also, right? Coming to the mechanical consideration, the thing what it is basically needed is, one is vibration analysis, that is structural analysis. Another one is the thermal analysis, right? One is structural, another one is thermal analysis, right? So for every machine, for any electric machine, just go for ANSYS packages for the thermal analysis as well as for the vibration analysis. Don't go for some other package, because it may take some time more, as well as the accuracy also is be high in case of ANSYS, and it is user friendly also for the structural analysis. Whereas in case of electromagnetic analysis, ANSYS is a difficult one. Now 7% of creating the efficiency map is ready now. So this one is the workspace for the motor saw, right? So in this case also, if you go to the new one, if you go for the new option, so there is different motor is available. So first we have to choose what type of motor we are going to use. If I select a BLDC motor, again we can be able to see, we are going to see a motor template here, right? Whereas in this case, we have to give the entire machine dimension. In this case of motor saw, we have to give entire machine dimension. But in the case of JMAG, this is not needed, right? In the case of JMAG, this one is not needed here. Right? In the case of JMAG, if we know only the power rating of the machine, we can able to simulate a machine. If we know only the power rating, we can able to simulate the machine. Whereas in case of motor saw, we have to know the entire machine dimension. Right? Then only we can able to solve the machine. Otherwise, the analysis in the machine is very tedious one. Right. So this is the motor saw now. So it is asking some specifications here, right? One is such as supply voltage, rated current, speed. So everything we have to give. And coming to the type of rotor, so there is different type of rotor. What are the rotors available? So everything is available here also. If you want to go for a different type of structure, we can go for the DXF file, that is the AutoCAD file, right? So everything we can go, right? Again, if you go for the general settings, so these are general settings such as air gap, stack length, and the rotor. Coming to the rotor dimensions, so each and everything we have to give. Each and every parameter we have to give. Then only we can be able to analyze the machine. So coming to the stator, see, everything we have to give, including the inner diameter, outer diameter. But in case of optimization, we have to go for another package here. We have to go for some other package. So this is a winding diagram for different phases. And if you want to see all the 3 phases at a time, how it is there, just click enable this one, and in this option give on. That is, we can be able to see how the current is traveling from one point to the another point, that is dot to cross, right? So this can be seen here by using the motor saw, right? And if I want to analyze the machine, right? So just go to the results here, and then go for the, what are the things you need. If you want to check the coiling torque, select the coiling torque. If you want to check the torque, give the torque and view result, right? So like that only we can be able to see. But the thing here is, we have to give the dimension for every part of the machine. Then only we can be able to analyze the machine. But in case of JMAG, it is not like that. In the case of JMAG, it is not like that. We can be able to analyze the machine easily if you know only the power rating of the machine. the RT viewer is creating. RT viewer is responding okay, we will close and then we will open it. I will just go, so this is the characteristics for the torque here. So by using the motor solve, we can able to see the characteristics for the torque, right? But in case of efficiency, it is not there, right? Efficiency we cannot able to see here, right? So only I told that the motor solve, when compare the JMAG with some other packages, the JMAG is very best one, right? I just go back to the RT viewer. So the RT viewer is this. Again we have to import the file.
Prabhu, audio suddenly reduced.
Sir, now sir?
Yeah, perfect. Can go ahead.
Okay sir, So again give the option as more. Now giving the efficiency map. So there is two map available, one is speed torque characteristics and one is efficiency graph, right? One is speed torque, other one is efficiency map, right? So we're coming to the analysis point of view. In case of mechanical, right? When we go with the thermal will be easy, right? So it will be run for some time. The JMAG RT visual will run for some time. So in the meantime, we will see the thermal characteristics, right? In case of JMAG also, we can able to do the thermal, right? So just in the JMAG designer, so in this 1.5 hour, I cannot able to fully cover the JMAG. So I just take the important three. One is Express Designer RT Viewer. Apart from this, there is Explorer also. So in a short way, I can say the JMAG designer, there is having a help option. In this help option, there is a self-learning system. In the self option, there is a self-learning system, right? So this self-learning system is having two things. That is practice mode. So in this practice mode, we are having a case study here. So this case study is having a 2D analysis, 3D analysis, structural analysis, electric field, RT model analysis, right? Similarly, the thermal also is available here, right? So everything we can able to perform here, and step-by-step procedure also is available here also, right? So coming to the structural analysis procedure also is available, and coming to the thermal analysis, the thermal analysis procedure also is available, right? So everything is available here itself, right? But the thing here is, we have to choose how the machine and what is the machine, right? So depend upon the type of machine, we have to give the input here, right? So everything we are having a self-study system in the case of JMAG, right? I just close this self-study system. So this self-study system is not having the thermal analysis for the motor, because if we apply the thermal boundary condition, right? The thermal boundary condition here, which is the heat source one, that has to be applied to the coil as well as the motor model. So that is a difficult one, right? So in order to overcome this problem, just go for the thermal analysis by using ANSYS packages, right? Just go back to the file here and import the thermal IGS file. I have the IGS file of a motor here. I just show what is the procedure in ANSYS to do the thermal analysis. So this is the IGS file. I just opened here. So right now, so this is the view of the IGS file of the thermal model. So meanwhile, we will check what happens to our efficiency graph. So it is still creating the efficiency graph. So we don't want to waste our time. So we will go back to our, so this is the thermal. Just click the thermal option and go to the preprocessor, add element. So the most of the procedure for the thermal as well as the vibration are much similar. But the thing here is the material properties also similar, right? So 7600 for the motor, and I not just giving the default value, some value for this, right? So I do. So just check the what is the specific heat of the different material. So I'm not going to give the exact material because lack of time. So for coil, I think it is 8694. Just check the density of coil also, and the different property of coil, and the shaft it is 1000, right? And the so now just go to the meshing here. If you go to the meshing, you have a meshing attributes. Just give the pick areas and give the coil, right? And then give apply here, and then go to the option 2 because 2 is the coil, right? And then again apply here. So just deselect the option which are not needed now, and this is option 1. Again the still thing is shaft, right? So the shaft be the third option, but I didn't give the option for the air. So again I want to go to the material properties and then give the material models, and then go back to our, so be the fourth one as the air model. So just pick the areas. So this is the area for the air. So I just select the air region as the option 4 and then just go to the solve option, mesh tool. So again go for the smart mesh. Again pick all. So in the meantime we will check the RT viewer. RT viewer is still running. Right. In the meantime we will go for the theta characteristics also. Right. So now again go to the loads analysis type, new analysis. If it is a transient, okay, give a static means okay, give a static, and define loads, apply thermal temperature lines, and the outer temperature is the room temperature, that will be taken as the boundary condition as 30. Coming back to the uniform temperature, that is temperature inside the machine, because inside the machine temperature will be higher than the room temperature. So I just given as 31, and select the area temperature, that is temperature founded in the coil. Either we can go for the temperature as the heat source, or we can go for heat generation as the heat source, right? So I give the temperature as 35, it's a default one. Suppose we are giving the heat generation as the input in the coil, so the formula for calculating the heat generation is losses divided by surface area. Losses divided by surface area of the coil, right? Losses means you have to include both ohmic losses as well as the iron losses. And then again we have to go back to our initial condition. So initial condition is available here, and define, pick all, and give the boundary condition as 31. That is the initial condition which is found inside the motor, and go to the solve and give the current LS option. So it is a transient one, right? So for the transient one we have to go to the solution control, right? For the transient one we have to go for the solution control, and then we have to give everything, right? What is the time we have to end here, right? Give us 100 and give us times step size. I just give randomly. So still 10 minutes more, just time step size is taken as 10, and minimum time step I just giving as 2 and maximum step size I just give as 4, right? And then go to the solution control here, non-linear one, right? I just go for the on option here, and here I just go for the 100 because the maximum iteration what I mentioned there, the maximum step size 4 is less than the starting time, right? So again go for the maximum step size. Okay, I just give here, just solve this one. So depend upon the properties of the material, depend on the properties of the material, the heat will be distributed now, right? So for the time being, I didn't give any accurate property of the material, right? I just give the value for material properties as randomly, right? The motion is going on. Now in the meantime, we will check this one. So again, it is running here. The efficiency map is going on, taking some time, right? But after getting the result for the efficiency map, the graph will be very much accurate for our publications. And the solution is done here. And just go to the general properties and go for the plot result, contour plot, nodal solution, DOF solution, nodal temperature. Okay, it is just a distribution. So this is how the heat is distributed, right? So the minimum temperature is 30 degree and the maximum temperature what I given is 35 degrees Celsius, right? So if I want to see how the heat is distributed in the machine, just go to the animate option here and then go for the deformed shapes. Again go to the plot control, again go for animate, go for the deformed results and then give OK. So now we can able to see how the heat is distributed inside a machine from the stator coils, right? So we can able to see visually how the heat is flowing from the stator coils to the different part of the machine, right? So if we give the accurate material properties, we can able to see the exact heat distribution inside a machine, right? So I just close here. Now if you want to plot a graph here, just go to the time is post processing and then go to the plus option, DOF solution, and then select the coils here because coil will give the maximum heat distribution, and then go back again go to the add option, select our stator, again go to the add option, select the rotor somewhere. So now we are having 3 options here. Select everything, right? We are selected everything and then go for the graph data here, right? We can able to get the graph data, right? So the graph data is constant somewhere. So suppose if you want to get the export the data, just give the export data option here and go to the browse and then go where I want to save. We can able to save this one in the Excel sheet, right? So just go to the plot and go to the areas. So this is the procedure how we can able to do the thermal analysis, right? So now we are obtained the graph for the torque speed characteristics, right? We are obtained the graph for torque speed characteristics by using the RT viewer. By using RT viewer, we are easily obtain the value for torque speed characteristics, right? So just go to the display option. If you want to get the Instead of going for the speed torque characteristics, we can go for the speed by the ID direct axis current as well as the quadratic axis current. So that also is possible, right? So just go for the speed versus and go for the display and then go for the different option which is available, right? So if you want to get the value of speed versus direct axis current as well as the quadratic axis current, just try that one, you will get the graph, right? See, we can able to get the speed torque characteristics for the AM, right? So that also is possible. So this is the characteristic for the speed torque characteristic for the maximum value of phase current, and the next option is the direct axis current as well as the quadratic axis current with respect to the speed. So that also we can able to take, right? So this is a plot for the direct axis current as well as the quadratic axis current. The red color indicates the direct axis, quadratic axis current, and the black color indicates the direct axis current. So still this one is not available. That is the efficiency plot. It is taking some time. It is creating, right? So we wait for 5 minutes, right? So until we will get the efficiency map, right? Because efficiency map is the important characteristics for the JMAG one. So in the meantime, if there is any questions, you can post in the chat box. In the meantime, if there is any question, you can post it because it is taking some time.